Hello, my name is Julio Rivera, and I will be doing my presentation on desalination and water shortages. Why should we care about the world water shortage? Well, NASA has stated that a human must have food, water, air, and shelter just to be able to survive. And it is estimated that on average, a human cannot survive more than a week without water. So, are you willing to gamble on your survival? What is a water shortage? A water shortage is defined as the lack of sufficient water resources, including a lack of access to safe water supplies to meet water needs within a region. Water shortages are expected to affect the entire planet by 2040, and according to Bloomberg, there are currently 17 countries that are extremely high risk of water shortages, which include Qatar, India, and Israel, as well as 27 countries that are at a high risk, which include Mexico, Belgium, and Turkey. Now, why is it happening? Well, although the Earth contains 326 million trillion gallons of water that does not leave our planet, about 97% of it is saltwater, which cannot be used as drinking water, and 2% of it is frozen, leaving only 1% of it accessible for safe human consumption. Out of this 1%, most of it is underground, which is difficult and expensive to obtain, hence why most human societies have been created near fresh surface water resources. However, because of the vast consumption of fresh water, both by development and increased population, some of these freshwater sources have begun to dry up. For example, in what is now Mexico City, there used to exist a giant lake. However, in its development, the lake was drained and filled by people. Now this begs the question, if surface water is running out, why not use water that is underground? Although groundwater or underground water deposits called aquifers are accessible for use, they are not only expensive to harvest, but have an extremely low replenish rate. This is because aquifers are replenished by seepage of precipitation that falls on land, and although their replenishment varies all over the world due to different rocks having different porosity and permeability characteristics, as well as other topographic and human factors, the rate tends to be between 50 feet per year to 50 inches per century. Another caveat to overly utilizing aquifers is that by extracting the water from the ground, the soil begins to compress, making it a structural liability to any city above it. Hence, why we should avoid as much as possible using aquifers. So our water supply is running out, but is our water demand increasing? Yes. We currently use 8% of fresh water for personal, 70% for agriculture, and 22% for industry. Over the past 100 years, our global water demand has increased by 600%, and according to the Food and Agriculture Organization of the United Nations, the annual growth rate is estimated to be about 1%, meaning we will need to either find ways to use less water or obtain water by different means. Otherwise, we could reach day zero, which refers to the date when a population water supply runs out. One alternative everybody's looking at is desalination. What is desalination? Desalination is the process by which the dissolved mineral salts in water are removed. Now, how does it work? Well, there are different methods, two of the most popular being reverse osmosis and thermal distillation. Reverse osmosis works by filtering out solid and other particles before utilizing reverse osmosis. In the reverse osmosis step, ocean water is forced through thousands of semi-permeable membranes under very high pressure, which allows for the smaller water molecules to pass through, leaving salt and other impurities behind. After that step is completed, pure water remains, and that's when minerals and chemicals are added to meet health and anti-corrosion standards. Now, thermal distillation works by filtering out solid and other particles from the ocean water. Then the water is heated, separating the vapor from the salt and other impurities. The salts and impurities are then collected separately, and the vapor is condensed to pure water, where mineral and chemicals are added to meet health and anti-corrosion standards. Now, desalination is not perfect by any means. It has its drawbacks. One of its drawbacks is the byproduct brine, which is super saturated with salt and the leftover impurities. And then when it is pumped back into the sea, it damages the nearby coastal ecologies, which is something we try to avoid. Another drawback is the fact that building a desalination plant is extremely expensive. So very few countries are actually able to do it. Now, what does the future of desalination look like? As droughts are becoming more consistent, a big push for desalination has come about. So there are currently new developments being brought forth, like zero discharge water treatment being incorporated, where temperature science solvent extraction mixes a low polarity solvent with brine at 41 degrees Fahrenheit, allowing to further separate water, and salt ions until they are completely separated.